Welcome back to day 58 of the Edulexis 90-day Python program. Today, we are stepping into real-world applications by building a fully functional weather desktop app from scratch. Imagine typing any city name into your own custom app and instantly getting live temperature, humidity, and wind speed. No complex software needed. Just pure Python, Tkinter, and live API integration. Let's dive right in and see how easy it is to build this step by step. Before writing any code, let's understand how our app talks to the outside world. We use APIs, application programming interfaces, which act like digital waiters. Our Python script sends a request to a weather server, and the server replies with live data. To make this happen in Python, we need the requests library. If you don't have it installed yet, just open your terminal and type pip install requests. It's that simple. Let's open up our code editor and start building. First, we import the core modules. We need Tkinter for building our graphical user interface window, requests for fetching live data from the web, and the message box module from Tkinter to display clean pop-ups when errors occur. Keeping your imports organized at the top of your script is a great habit for clean and maintainable Python programming. Now let's create the graphical window where our users will interact with the app. We initialized Tkinter by calling tk, set the window title to Edulexis Weather App, and configure a fixed window size, like 400 by 500 pixels. We also set a clean background color to give it a modern desktop feel. Let's run this initial code to verify our blank canvas pops up perfectly. A great app always needs a clear header. Let's add a welcoming title label at the top of our window. We use tk label, pass our root window. Set the text to the live weather finder, choose a bold font so it stands out, and pick a nice dark text color. Then we pack it into our window with some vertical padding so it has breathing room. Clean spacing makes your UI look professional. Next, our users need a way to type in the city name. We create an entry widget using tk entry, which acts as our text input box. Right below it, we add a search button using tk button with the text get weather. We configure the button's command parameter to point to a function we are about to write called get_weather. Whenever the user clicks this button, Python will execute our call logic function. We need a place to display the weather results. Once fetched, let's create 3 output labels, one for the temperature, one for humidity, and one for wind speed. We initialize them with empty text strings for now, using a clean, readable font size. By storing these label widgets in variables, we can easily update their text dynamically later when the API response arrives. Now comes the exciting part, writing the backend logic inside our get_weather function. First, we grab whatever city name the user typed into our entry box using city_entry.get. We strip any accidental whitespace to keep our input clean. If the user left the input box empty, we immediately trigger a warning message pop-up so they know they need to enter a city name before searching. With the city name ready, we construct our API request URL. We use a standard weather API endpoint and pass our city name and API key as parameters. To keep your code secure and professional, always store your API key in a variable. We format the URL dynamically using Python f-strings, combining the base endpoint, city variable, and key cleanly into one request string. Now we send the request to the server using requests.get URL. The server responds with a JSON object, which is essentially a structured dictionary of data. We convert this response into a Python dictionary using response.json and store it in a variable called data. Let's print this data to our terminal temporarily so we can inspect how the weather information is nested inside the JSON structure. Let's look at how the JSON data is organized. The temperature is inside the main dictionary under the key temp, and humidity is right beside it. Wind speed is found under the wind dictionary key. We extract these values safely using key indexing. For example, temp equals data, main, temp. By extracting these specific keys, we isolate the exact numbers we want to show our users on the desktop screen. Now that we have successfully extracted our temperature, humidity, and wind values, it's time to update our desktop app interface. We use the configure method on each of our output labels to update their text dynamically. For instance, temp_label config text equals F temperature, temp, degree C. When the user clicks search, these labels instantly reflect the live weather data fetched from the server. What happens if a user types a fake city name like Atlantis? The API will return an error status code, and our app might crash if we aren't careful. To prevent this, we wrap our API request in a try except block. If a connection error occurs or the city is not found, our code catches the exception smoothly and displays a friendly error pop-up instead of crashing the program. Robust error handling is the mark of an expert programmer. Let's put everything together and run our complete Python script. Our desktop application window opens up cleanly. Let's type in London or New York and click the Get Weathered button. Look at that. Instantly, the live temperature, humidity, and wind speed appear right on our custom desktop interface. Everything works smoothly and responds instantly to user input. Fantastic work today. In just 15 minutes, you've built a fully operational weather desktop app, combining graphical interfaces, the requests library, JSON parsing, and robust error handling. This is a massive milestone in your Python journey with Edulexis. For your daily challenge, try adding a weather icon or background color that changes based on weather. It's hot or cold. Practice consistently, keep building, and I will see you tomorrow in day 59.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.